You know, if you peek inside almost any modern data center, there's this one piece of technology that's so fundamental, it's almost invisible. Well, today we're going to pull back that curtain and talk about VMware and the incredible engine that makes it all work, the hypervisor. So let's just dive right in and break it all down.
Okay, let's kick things off with a question that might sound a little strange at first. How is it possible for one single physical computer, that metal box humming away in a server rack, to pretend it's 5 or 10 or even 50 different computers, all running their own thing, all at the exact same time? It sounds kind of like a magic trick, doesn't it? But that's the whole reason virtualization was invented in the first place.
And the magic behind that trick? Well, it has a name: the hypervisor. This is the absolute secret sauce. The easiest way to think about a hypervisor is to picture it as a super efficient traffic cop for your computer's hardware. It's this thin layer of software that wedges itself between the physical machine and all the virtual machines running on top. And its entire job, its only job, is to take all the real resources, the processor power, the memory, the storage, and just slice them up, handing out pieces to whichever virtual machine needs them.
But here's the thing, not all hypervisors are built the same way. When it comes to how they manage that hardware, they basically take one of two totally different paths. And understanding this fork in the road is really, really key. Let's look at what we call the bare metal approach versus the hosted approach. And when you look at how they're built, the difference is night and day. So the Type 1, or bare metal hypervisor, that's the high-performance champion. It gets installed directly onto the server hardware. It literally becomes the server's operating system. There's no middleman, which makes it incredibly fast and efficient. Now the Type 2, hosted hypervisor, that's different. It runs just like any other app on top of an operating system you already have, like Windows or Mac OS. It's always simpler for, say, running on your laptop, but that extra software layer, it definitely adds some performance overhead.
So when we talk about a Type 1 bare metal hypervisor in the world of VMware, we are talking about one thing: ESXi. This is the lean, mean, purpose-built engine that absolutely powers the world's enterprise data centers. And that lean part is so important, because its small size means there's less to go wrong and a much smaller target for security threats. And that is exactly what you want when your most important applications are on the line.
And then, on the flip side, the classic example of a Type 2 hosted hypervisor is VMware Workstation. If you're a developer and you need to, run a Linux environment on your Windows laptop just to test some code, this is your go-to. You install it just like you would any other program, and boom, it lets you create and run entire virtual machines right there on your own desktop. Super handy.
Okay, so we've got our core engine, right? The ESXi hypervisor. But let's be real. In an actual data center, you're not just managing one of these things. You could be dealing with hundreds. So to manage that kind of scale, you need something more. You need a unified platform. And that, my friends, is where VMware vSphere enters the picture.
See, vSphere isn't just about running a bunch of virtual machines. It's a full-blown platform that's all about automation and availability. And what does that really mean? It means it transforms a boring collection of servers into this dynamic, living pool of resources. It means it can automatically move virtual machines around to balance the workload, or, and this is the really cool part, it makes sure they recover instantly if a piece of physical hardware ever fails.
The formula for vSphere is actually beautifully simple when you break it down. You take the ESXi hypervisor, that's the engine, and you pair it with something called vCenter server, that's the central brain. vCenter gives you what everyone calls a single pane of glass, which is just a fancy way of saying it's a centralized dashboard where you can see and control all of your servers and virtual machines from one single spot. You put those two together, ESXi plus vCenter, and that equals vSphere. But the story doesn't stop with just servers, not even close. This core idea of taking physical hardware and turning it into a flexible, software-controlled resource, it's so powerful that VMware just kept going and applied it to the entire data center. So let's zoom out for a second and look at the bigger picture, the whole VMware ecosystem.
Now you start to see this pattern, right? This idea just expands. VMware NSX, for example, does the exact same thing but for networking. It takes the functions of physical switches and routers and turns them all into lines of code. And then there's VMware vSAN, which does the same thing for storage. It pools together all the physical hard drives from a bunch of different servers into one giant shared resource that's all controlled by software.
And that's really the whole journey, right there. We started with a pretty simple problem. How do we run 10 machines on one physical server? But by applying that same principle over and over again to networking, to storage, we've ended up with the ability to create an entire software-defined data center, a place where all the infrastructure, compute, network, storage, the whole shebang is just managed as flexible, automated code.
This whole transformation leaves us with a pretty big final question to think about. If software can completely redefine our relationship with physical hardware and just shatter all those old physical barriers, what's next? What other constraints that we think are permanent are just waiting to be turned into code? That's definitely something to chew on.